All right, so for the Hydrate lab, we have this data over here. Now these numbers are not gonna match your numbers. They're just made up numbers, but I'm gonna use them as my example. So I numbered them also on the side so that you know what I'm subtracting when I do these things. So first of all, from the actual lab, you figured out from using the balance, the mass of the evaporating dish, which was 43.07 grams. And then we put the magnesium sulfate in there, and then we found the mass of both of them. So that would be the evaporating dish and the Hydrate magnesium sulfate, and I made it heavier, so it's 46.12. Line number 3 would be subtracting those two. So when I write 2 minus 1, what I mean is you're subtracting this value from this value. So 46.12 is the mass of the evaporating dish and the Hydrate, and then the mass of just the dish is 43.07. So when I subtracted those two, I got 3.05. So for whatever you get goes there, and that's the mass of the hydrated magnesium sulfate. All right, so that's all before the lab. Then you guys actually did the lab, which was taking that evaporating dish, heating it up, getting all the water out of it. Removing the water made it lighter, so it went from 46 grams down to 44 grams, at least mine did, okay? So that was the mass afterwards for the evaporating dish and the anhydrous. So to get the mass of the anhydrous, which is just the dried out magnesium sulfate, I need to remove the evaporating dish from this. So 4 is gonna be both of them. 4 is the evaporating dish and the anhydrous. And then I subtract 4 from 1 again because I want to get rid of that evaporating dish. So when I do 44.72 minus 43.07, I ended up with 1.40. All right, mass of the anhydrous. Oh no, that's just kidding. Subtracting those two, I should end up with 1.65. Let me fix that real quick. 1.65. Okay, so that is the mass of the anhydrous that I got there. Now, number 6 is the mass of the water in the hydrate. So for this one, I know that the hydrate magnesium sulfate is 3.05, which is line 3. And then I know the anhydrous one, that means it doesn't have any water in it. That's line 5. So to get this, I'm going to subtract these two, 3.05 and 1.65. That's going to give me the 1.40. So this is the grams of water, and then this is the grams of the anhydrous magnesium sulfate. So now we have grams of both of those. And now it becomes a problem just like we did in class, where you need to convert those from grams to moles, and then divide by the smallest one to figure out your hydrate, all right? So the next thing that we're going to do is we're actually going to do the grams to moles part. So let me set that up. So we'll have 1.65 grams of magnesium sulfate over 1. All right, so we're going from grams to moles, so the bottom will be grams. All right, this will be moles. 1 mole, and then the molecular mass of magnesium sulfate I got was 120.38 grams there. All right, so I take 1.65, I divide it by the 120, and that'll give us our moles of that, which I didn't write down, so we'll do that in a second. And then I'm gonna set up the other one, which is going from moles of water. So grams of water is 1.40 grams of H2O. Over 1. 18.02 is the molecular mass of water. So 1 mole. All right, and again, I don't have that calculation, so we'll do that in a second. Okay, so I plugged this into the calculator. I got 0.0137 moles of magnesium sulfate, 0.0777 moles of water. To figure out the actual hydrate for this, we have to divide by the smaller number. So it's going to be the 0.0137. All right, that's going to give us MgSO4 in association with whatever we get when we divide those two. So 0.0777 divided by 0.0137 gives us 5.67, which is not a great number because we want that to be a whole number. Now that's okay, we're just gonna round it to the nearest whole number, because again, this is what we did in the lab. It didn't work out great. So I'm gonna round it to a 6. And that'll give us 6H2O, all right? And then just for filling in number 7 here, this is moles of anhydrous, so that would be this, 0.0137, and this is 0.0777. Okay, now that we know that our data, like what I got from doing all my numbers, was magnesium sulfate in association with 6 water molecules, and we know that it's supposed to be 7, now we can figure out our percent error. So for this, our accepted value is going to be our MgSO47H2O, and then that's going to be minus our experimental is going to be MgSO4. Mine is going to be 6, because that's what I got here. Yours could be anything else, all right? And then the bottom one's going to be MgSO47 as well, because that's what it should have been. Now, if you're like, well, how do I make these numbers? You already know how to make them numbers, right? You just use the molecular mass. So we just look at the periodic table, we figure out the molecular mass for all of this, and we plug it in. So I'm going to do that down here. All right, so magnesium sulfate, we already know the molecular mass of that. I'm putting a little thing here because it's the absolute value of all of this, so that's what the line there is. So then 120.38 is the molecular mass of the magnesium sulfate, plus 7 times water is 18.02. All right, so 7 times 18.02. So all of that is the accepted value. All that's going to happen, so I'm going to put parentheses around it, minus the magnesium sulfate with now 6 water molecules. So again, it's going to be 120.38 plus, now it's going to be a 6 waters. All right. Order of operations is real important. Make sure you do everything in here first, then subtract them. All right, and then on the bottom, it's going to be the same thing as over here. So it would be 120.38 plus 7 water molecules. All right, so now I'm going to punch in these numbers, and then what we would do is multiply it by 100%. Okay, so let's see what we get. All right, so when I did this part, I got 246.52. Minus, mine was only 6, so minus 228.5, and then divided by the 246.52. When I did all that, then times it by 100, I get 7.3098%. There's 5 sig figs in pretty much everything. This should have a 0 here. So it should be 5 sig figs. All right, so I have a percent error of 7.3098%.